The thought process with this problem is to understand fractions as exponents, as well as some of these higher order roots. And the first thing that they talk about is this rule right here, that if you have a power to a power, you multiply those exponents. And it's pretty straightforward, and I can give you an example very quickly, that if you had like x squared cubed, well, that's the same thing as x squared times x squared times x squared. Notice the 3 times there. And you may take a step back and think about how each one of those x squareds means 2 x's. So we're left with x to the 6th power. And the thought process is to help you understand why the x to the 1/2 is the same thing as the square root. So, I mean, that's the lesson to be learned here. Because the thought process is that x to the 1/2 squared is equal to x to the 1/2 times 2. Well, half of 2 is 1, and so you're just left with x. And so the thought process is, we understand that the square root and the square undo each other, so the square root of x squared is also equal to x. So the thought process is, if you square both sides and you get the same thing, see how we squared both sides? That must mean that what's in the this piece must be equal to this piece. So that's the whole theme in this, is x to the 1/2 power is equal to the square root of x. And you're welcome to use a calculator, because if you were to type into a calculator 9 to the 1/2 power, it gives you the same answer as if you did the square root of 9. Same thing with 100. And you can even make it as to the 0.5 power. That's the same thing as 1/2. Is the same thing as the square root of 100. Yeah, so this will help us as we move forward. And it's actually the same for any index. So if I were to ask you to evaluate 8 to the 1/3 power, that's the same thing as the cube root of 8, which I suggested you get used to doing. But remember, our work that might have helped you remember the cube root of 8 is that we could break it down, and this number tells you how many groups you want. So I don't know if you remember, the 4th root of 81 is exactly 3. But it might have helped you to think about 9 and 9, and then 3 and 3, 3 and 3. And we were looking for a group of 4. So what's tricky about the next one, and this always stumps students, is yes, it is the cube root of 125, but the negative power puts it 1 over the cube root of 125. And so I think at some point I suggested you remember that. But if you go to a calculator and you type in 125 to the negative 1/3 power, notice that my answer is not negative. It is a fraction. And if I change it to a fraction by hitting math frac, enter, you get 1/5. So we have the right answer. Same thing with the next one. The negative power is saying, hey, it's 1 over the 4th root of 256. And your calculators actually do the 4th root. So if it helps, you can hit the math key, scroll down until you get to this option, and do the 4th root of 256. And we get 4, but remember it was supposed to be 1/4. So there's a couple options on how you could get there. So moving on to the next one. That's why I would go over it, is just because you have a negative exponent does not mean you get a negative answer. What it means is it turns into 1 over, it is the 5th root of x. So that corresponds to option 2. Okay. Feel free to re-watch this video or hit pause and try some things on your own. Because this next rule is pretty important. Because if we were to look at this problem and we have x to the 4/3 power, what you could actually do is rewrite it as x to the 1/3 power to the 4th power. If that doesn't resonate with you, think about how if we did a power to a power, you multiply the exponent, and multiplying a whole number by a fraction just goes into the numerator. So this is equivalent, but this is the answer they're looking for. Now they also want you to think of this problem a slightly different way, because what we could have done, switch this with orange, is flip these two numbers around, but multiplication is commutative, so that would have been fine. That maybe you could write it as x to the 4th and then to the 1/3 power. So this would also be equal. So all of these are equal. So this next problem, I'm not really a big fan on how it's written, but they want you to think of it as, so maybe I'll do this one, I'll just draw an arrow straight through. They want you to write it as the cube root of x to the 4th power. But you might not like the problem written that way. You might prefer seeing the problem written this way, x to the 4th power first, and then the cube root of that. But these are equivalent. So maybe you want to do this problem as this, what I just did in orange, that you do 8 to the 4th power first, and then cube root. Now here's the thing. I don't think I would do this because I don't know 8 to the 4th power in my head. So that's why it's beneficial if you know some of your cube roots and you do the cube root of 8 first and then to the 4th power, because I know the cube root of 8 is 2, and then 2 to the 4th power would be 2, 4, 8, 16. But I will point out that this, what I had in orange, is going to still give me 16 if I go to a calculator, whether you do 8 to the 4/3 power, or if you do, let's see, math, the 4th option here is the cube root of 8 to the 4th power, or if I pretty much do that same thing and remove that there and move the 4th power on the outside, you still get the same answer. So this will all be useful down the road. So the whole goal is that you do not need a calculator. I mean, I'm not mad if you do, but it actually is helpful to practice without a calculator first. For instance, do you know the cube root? What's in the denominator is the index, and then in the numerator is your power. So as long as you know the cube root of 27 is 3, and then you can square that, the problem is not too bad. I would even argue for the same one. It's the square root. Now, you don't have to write an index of 2. Whoops, getting ahead of myself. It's the square root of 4, and then take that number to the 5th power. Well, I know the square root of 4 is 2, and then to the 5th power, 2, 4, 8, 16, 32. I'm multiplying by 2 5 times. And as a reminder, the negative power makes it into the denominator, the 4th root of 16 cubed. Well, I know the 4th root of 16 is 2. Double check my arithmetic. But then 2 cubed is 8. 2 times 2 times 2. And then this last one, I think they're trying to trick you here. But you want to make sure you do each power. So you do each one individually. It's the cube root of 8 squared, and then times the cube root of x squared. So, I mean, doing the numbers will give it away. So let's look at the variables. Notice that it matters that the cube root is the index and the squared is the power. So this is not the correct answer. And then the cube root of 8 is 2. That once I once I square it, is 4. So it is 4 cube root of x squared, leaving me with option 1. I wasn't trying to rush through it, but it seems like I rushed through this because a very short video. But you should be ready for the homework now. Try your best without a calculator while you work through it. I'm not upset if you resort to it, but you should be able to do this without, or you should be able to do a lot of these without a calculator, and it will help you down the road. So try it.